Hello, I am Leah Gutierrez in Mr. Yoon's Period 4 Honors Chemistry, and I'm going to be demonstrating to you today the experiment elephant toothpaste. So it's just a simple experiment. We need a few household items. So I have about half a cup of 20 volume hydrogen peroxide, and in here I have about a tablespoon of liquid dish soap, just any liquid dish soap. So right now I'm kind of going to swirl it so I can get everything like settle through, like mix the soap. And use the cap and just kind of shake it so the soap gets evenly in the solution, the hydrogen peroxide. And now I'm going to add some food coloring, and it can be any color you choose, just whatever you want your elephant toothpaste to be. So 1, 2, 8, about 8 drops. And 10, you could increase it what color you want to be. And I'm going to shake that. Okay, so right now I have the 20 volume hydrogen peroxide, the dish soap, and my food coloring. Okay, and now then you're going to have a packet of active dry yeast, and I have it with some warm water, and you just kind of mix it up to get it in like a liquid flow, all liquid. Okay, now I'm going to pour it into here is the reaction. And the reaction starts when you add the yeast because the yeast is acting as a catalyst, which is speeding up the rate of the reaction. And it's speeding up the reaction of the hydrogen peroxide, which is H2O2, decomposing into H2O, water, and O2, oxygen. And the foam is just it's basically just foam of soap, water, and oxygen. And the bubbles are just filled with oxygen. That's why it's so light and foamy. And yeah, I mean the foam that is created is harmless. You can touch it. It's not poisonous. It's just the soap. But obviously, since soap, you don't want to use it as actual toothpaste. It's called elephant toothpaste because it looks like toothpaste usually is. It kind of looks like that consistency in the color. But obviously it's a lot bigger than actual toothpaste we use, so that's why they call it elephant toothpaste. This is an at-home experiment, but you could also do it as a lab experiment and using a higher volume hydrogen peroxide, like a 30 volume hydrogen peroxide. And instead of the yeast as a catalyst, you could use like a saturated solution, potassium iodide, Ki, and that would be a different catalyst. It'd also be a bigger reaction. I mean, the bottle is warm because if you do the experiment, you could tell the bottle is warm. The bottle is warm because it's an exothermic reaction, so that it is releasing heat. The hydrogen peroxide naturally decomposes into oxygen and water, but the catalyst yeast just speeds up the reaction. And it does it so quickly that the foam is produced because the foam is just filled with oxygen. Because the catalyst is just removing the oxygen, it's breaking it apart because it's a decomposition. So it's taking it from the single H2O2 into to oxygen and water. Since it's removing the oxygen from the hydrogen peroxide, and it does it so fast, that's what creates the bubbles, because it just speeds it up. And since it's happening so fast, the oxygen has nowhere to go, so it goes into the soap, forming the bubbles in the foam. Well, I hope you enjoyed my demonstration of the elephant toothpaste. And I hope that it is an experiment that you'd want to do one day at home. Okay, thank you.